simulation, go here, run simulation. The same stimulus has to be written, ESS 1.8 V2 in 0 pulse. So we have written our stimulus, run the simulation. The ngSpice will open. Yeah, drag and drop the input and the output. So this is similar to what we have seen in the schematic. Red is the input, yellow is the output. So if we go to measure it using the cursors, it will be the same. Let's say the fall time. You can do multiple levels of zoom here. So the fall time, that is this one, is 2 nanoseconds here. So that's what we have defined it here. So this is the post layout simulation. So that completes our design flow as far as the analog and mixed signal are concerned. Likewise, we are done with our syllabus as well, wherein we have seen the schematic entry and simulation for a MOS differential amplifier, but we have seen it for a CMOS inverter. Layout of a simple CMOS inverter parasitic capacitance simulation we have seen. So instead of a 10-bit 10-bit numerically controlled oscillator is one of the examples, but again we have seen the standard cell approach using a CMOS inverter. Likewise, you can create a 10-bit numerically controlled oscillator as well. Automatic layout generation is one that we have not really seen actually. So if you remember the LVS cross probe, from here from the layout our schematic is getting generated. Likewise, there is a step wherein from the schematic the layout will be generated. Unfortunately, that part of the tool is not installed at the moment here. So but we can promise like automatic layout generation, that is the Scatur tool. I'll just show on this part. If you see, the Scatur is a schematic, sorry, the Secors, the automatic driven layout product. This part, schematic driven layout product, that is the automatic layout generation. So the schematic drives the layout. So Secors is for automatic layout generation, so that creates a layout from the schematic. But none of the automatic layout generators are purely 100% automatic layout generators. So it converts the layout from the schematic to certain level, and you may have to do some extra work on the layout to make it a proper 100% working layout, and then go into the simulation, the post layout simulation, and the final output file goes for GDS, that is the fabrication, that's the GDS graphical database system, the GDS2 file, which is a tape out that goes to the foundry. So this completes our demonstration of SLAM, the tool from Stabie Soft, and we can promise that all the experiments as per syllabus can be 100% performed, and this is very much of a research level industrial tool, wherein it has got a lot of translators as you see here, which can exchange the files between the different levels or the different tools of a CMOS VLSI technology. So you have complete portability as far as the import and output of the files with other industrial tools are concerned. So you can be assured that the syllabus experiments can be completed, and if you're upgrading to MEVLSA or go for any research activities as far as an industry collaboration is concerned, we can strongly recommend Stabie Soft for that, and we can certainly give the technical support as far as research activities are concerned, because we want to make Stabie very popular because it has got everything that is required for a CMOS VLSI design. And say for example, if you want to fabricate an IC also, we can certainly give the technical support. We have got the backing of ARF Design. They are ready to give the references, and definitely support is 100% assured. And the last thing is, as far as the tool is concerned, it works on Linux. So the working of Linux is, as said, it's not difficult at all. So after starting from the terminal window, the slam rest, everything looks like, whether it's Windows or the Linux, everything is the same. So it does not, you need not be worried about Linux. So we'll help you on that, and all we need is a network of PCs, wherein, say for example, we would require an example. If it's a 10 user license, we require 10 desktop PCs. Of that, we'll make one of the desktop as a server. We don't need your actual lab server or college server. Only 10 computers, which we make one as a server, and the license will be put on that particular server, and all the remaining 9 computers will access this license through the network. So an computer, 10 computers with a proper LAN connection is required. So we will do the Linux installation and give you all the training as far as installation of Linux is concerned, or the Stabie tool is concerned. So you can be assured that this lab setup is going to be a great success with Stabie Soft. We definitely can give you all the support. So if you have any clarification, you can certainly call me. I'm Vinod. My mobile number is 98947 67447.